we'll go ahead and get started. A little bit of context on what it is that's expected of you as you see up here what may or may not be on there. Okay, as a review, as you look at this, I would expect there's a lot of information you can tell me about chromium. And what would that be? Yeah, but that's not going to help you with what we've talked about. So it does, but not for the reason you're thinking.
It has 24 electrons.
No. It's got 24 protons.
Never mind, I meant that.
Scott.
Okay, now, when you said 28, you didn't just pull that number out of the air. How did you get that?
I know. You take 52 subtracted by 24. Yeah.
Right, and that gives you 28. So now, that's true if it was neutral, but it's not neutral. It's an ion. So should this 2 not have been there, then what would you put here? Then you'd put 24 here. But since we do have that plus 2, that's telling you you've got 2 more what? Well, it did before it gave it away.
2 more
Protons.
electrons.
2 more protons than electrons. So then that means this is 22. Okay?
Wait, so is it just with the plus 2?
No, it could be the other way around. If you had, let's see here, 16 and 8. If you did that.
Like, it has to be 2.
No, you could do chlorine. That's -1.
So if they don't have a charge, then
Then it's the same as the protons, if that number's the same. All right.
If it has 2 less, then it's 2 more.
Yeah, so if it's -2, it's 2 more than
It's
So if
2 more electrons if it's a negative charge. 2 less if it's a positive.
If I had 2 less, it would be 26 then?
Yes, then it would be 26 if this had a -2 charge, but metals are not known for having negative charges.
So with boron, like with plus 3, would you count that?
Yes.
Oh, brother.
Okay. Questions on that?
What about like the ones that have multiples? Like the one that has.
You'd have to be told that, though. We can't just expect you to know this, because this can have a +3 charge, too.
Yeah.
We got to tell you what it is. We don't. Otherwise, we're going back to memorizing that whole table. We don't want you to do that. But you do that with band music. You got to memorize that. Yeah, so maybe you're in band. Oh, you're not? I thought you were in band. Oh. Okay. You're in band. Just have you memorized that whole table?
Nobody asked.
I suppose, yeah, I would agree because you haven't tried.
I'm in band.
Yeah, nobody asked.
Okay? Now, moving on, what would you guess we're doing with these other 2 substances?
Find the atomic mass of it.
Yeah, you could say atomic, well, not atomic mass, because then you're including neutrons.
find its
Molar mass. Okay? So, how do we do that for sodium? I was going to see if you remembered how to write sodium phosphate, but I thought, well, you might not remember those. Oh, jeez. Genius. Brick, 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 brick. Okay? All right. Okay. Man, if we were ahead by like 20 or 30 points and you're at the free throw line, you have friends that go, brick,
Kenny's
brick,
gonna be saying
brick, brick, brick.
I'm gonna have like 40 points gonna be going to the school record or something. Mr. McKenny's gonna make me brick my one and only free throw I have left.
turn brick,
Something like that, sure. Okay, so for sodium, the atomic mass is what?
22.99.
Okay? And how many of them do you have?
3.
Okay? So that gives you a number. Atomic mass for phosphorus.
69. Phosphor.
68.9.
Isn't it that?
Yes.
208. No, it's
Oxygen is 16.
Okay? And then oxygen's what?
16 times 4.
64.
64 cents.
34.
69.
Got that one.
The top one. 69.
I don't want to calculate this stuff. I'll put it together.
See, I'm going to cheat. And,
Chad, you're doing
oh, this is a hydrate, so it's going to have water added into it.
If you're doing the chat, I'll just show up your calculator. You guys didn't know. Chad, if you didn't know.
Okay. See, the idea was, I had the bottle here, sodium phosphate, but notice it doesn't say that. It says 380 because it's got that water in there. It's because it's a hydrate. So you got to account for that 12 molecules
Sigma.
Why does
of
cold
that.
water and then gum make your really?
Oh, I just want you to talk about this. So,
Okay.
the
Battery almost
chemical in it
is almost
physically changes
done
it
here.
enough, it just, it's like a chemical.
That's what you were saying.
Okay, sorry. Something about gum.
So, why does like ice cold water and then gum make it like extremely cold, like and it burns your throat to drink?
I would say it's the flavoring. It has some oil in it. So then that flavoring gets in the back of your throat and it just magnifies the issue, magnifies that feeling of being cold. So just the opposite is how many, I came this close. I really wanted to do it, but I chickened out. Taking cucumbers and making spicy pickles. How many people like spicy things?
Disgusting.
And so if you're making spicy pickles to go into the canner, what spice do you suppose you're typically adding? It's a pepper. Can you be more specific? So I put jalapenos in there,
Kanye.
but the next one up starts with an H.
Habanero.
Habaneros. I just could not get myself to put a habanero in there
Why?
because of the Scoville units.
What's that?
There's like a decent
Okay.
jump, isn't it?
It's a big jump. Okay. Do you know what the Richter scale is in earthquakes?
I know earthquakes are.
Well, so if you have an earthquake and the magnitude is 5.5 on the Richter scale, if that goes up to 6.5, it's 10 times more powerful. Even though it's just an increase in 1, it's 10 times more powerful. If you do that, then I don't know if that means you squared that, and it's 100 times more powerful. The damage is 100 times worse. It doesn't mean that it is for sure. It just means that it can. Yes?
It says the habanero has 150,000 to 325,000 Scoville.
Whoa.
Okay. And then, of course, that jalapeno is a little bit further down. Yeah.
Jalapeno is 2,000 to 8,000.
Right. So I don't know if I could have handled. It sounds like some of you probably could handle that.
My grandma
I would try it. I don't like pickles.
So some people, yes, some people. Ran out of power with that microphone, with the batteries. I don't think this is going to last much longer, but we'll certainly give it a try. Okay, so 163.97 for sodium phosphate. So let's go ahead and do lauric acid really quickly. And then some of you going left to right, just do one element at a time. And there's nothing wrong with doing it that way.
So if you have the 2 and the 10, you know, in the
Okay.
parentheses,
Yes.
you gotta do 12, right? Or, I bet 20.
20. Yep. So then if you did these one at a time, looks like we got 10, 11, and 12. So 12 times 12.12. You've got 20, 23, 24 for hydrogens. 4.24. And then you've got 32 remaining with your oxygen. Okay? All of those added together.
200.36.
Close. This says 200.32. But yeah, 200.36 would be just fine.
We're just a little bit off on that.
I mean, if you come up with something like 201.36, then it's wrong. But if you have 200.11, 200.85, then that's fine. If this is off, then there's going to be problems. But if the decimal's off by just a little bit, it's just a little critical rounding error. It's not that important. Well, it is, but for our purposes at this level, it's not that important. Okay. So then what we want you to think about is, we'll wrap this up, how many atoms of lauric, you just need to make up a number.
7.
Okay? 7 times
2.34.
7 times 10 to the,
To the 32nd.
okay, 30 seconds. So 7.32 times 10 to the 32nd atoms of lauric acid. And we can do that because we've got the formula for lauric acid right there. So rather than writing this out each and every time, we just put La there. So do you want to work on this on your own? Okay, so I'll just go ahead and hit pause. Then you can work on this on your own time. Okay, we'll go ahead and wrap this up before I run out of power here. And we'll go over in our class period. Okay, so we know it's a 3-step problem. And we see atoms or molecules, so we know we have to use Avogadro's number. Okay? So if that's the case, Avogadro's number, does that go on top?
Bottom.
On the bottom.
Bottom.
Okay? Okay? And how many, it's atoms of what?
LA.
Lauric acid. And then
Uh-oh.
for this many atoms of Avogadro's number, how many moles do we get?
1.
Get 1 mole of that substance. Then your atoms are gone. How do we get from moles to grams? Now you're on the home stretch. Moles to grams.
You put the other mole in the bottom right.
Moles goes down here. And then what goes up on top? And you don't have to reinvent the wheel here, because we did that right here. So this number goes where in this problem? Okay, 200.36.
What makes this a 3?
Why did we get
What first time for class of lauric acid?
Oh my gosh!
Oh, okay. It's like yeah, you have to find that.
Now,
Starting here.
I understand some people may decide, okay, I'm just going to take this shortcut and I'm just going to put the mass here. And that's fine, but when you get further down the road, you're just going to confuse yourself. That's just my opinion, okay? And we want you to have a really good foundation for when you may or may not have to take this in college, okay? Because not only it might be expected that you show this, okay? And in college, you would agree they probably go a lot faster, Not that we need to go faster because we don't, but we still want you to be successful and have a good background. Any other question? Is someone going to give an answer then?
You got 2.44 moles. I mean, yeah,
To the 11 times.
grams, I meant.
Sigma.
To the
There should be an exponent for that.
times 10
Yeah,
to
times
the
10 to the 11th.
Okay. Times 10 to the 11th grams of lauric acid. All right. There we go. So that's all I have. Evaluation tomorrow, last day of the week. Short week next week as well. And then we'll get a little bit of time after these evaluations. You can put your calculator away because we move on to the electrons. Your slide rule. Bohr models. Configurations. Quantum numbers. But that doesn't mean anything to you right now. We'll catch up to you next time.